All right, so before we start, some housekeeping stuff. So we'll have another daily quiz today. That should show up on Canvas now. Once again, I wouldn't open this until we cover it in class. It's going to be due by the end of the day next Tuesday. All right, so kind of 2 class periods after we go through it live. That module 4 reading, although we will start it today, it's not going to be due until we really just have 1 class period devoted to module 4, which will be on Monday. So it's due before we start class on Monday. Excuse me. The first quiz, right, isn't going to be due until the end of the day today. So for those of you who have taken it, you shouldn't be able to observe the correct answers yet. After that due date passes, it should be open for review. I think, grading issues with 3 of the questions, just in terms of some decimal issues. And then there's one that has a formula that was entered in incorrectly. It flipped employment and unemployment. So if you calculated correctly, you're getting the exact opposite result. So I will kind of update that one after the due date passes. And I'll likely, I'll just give everybody credit for that one, but you'll be able to observe what the correct answer is once that due date is passed. Okay, so you might see your scores from your original submission if you've already taken it, update a little bit because of those changes that we made after the due date. Okay? So I went through quiz 2 to make sure there's no more of those decimal issues. Kind of had a similar thing with Top Hat. So that should be kind of all resolved after that due date passes. Other than that, I said I would post that first Canvas discussion today. So I believe I have that set to be due by the end of the day next Wednesday. So next Thursday will be our first exam. So I would suggest trying to get this done well in advance of that so you can start to focus on reviewing that first quiz. We'll have the second quiz posted after class on Monday. We should be able to finish module 4. And that second quiz, I'll have it set to be due 2 days following, so the end of the day Wednesday. But the answers I will have set for review as soon as you take and submit that one. It's a little bit different than the first quiz, just so you have more materials to kind of study for that. Final, I'll also get up a set of practice questions for class on Monday, which will have practice questions for that quiz that cover modules 3 and 4. But this Canvas discussion, right? So I put up a link here. So this is how it's gonna go. So I gave you 3 different kind of questions, bullet points, topics. You need to choose 2 of them. So each one kind of gives you an AI prompt that you will enter into whatever generative AI tool you choose to use. This could be ChatGPT. I believe you should have access to that as a IU student. You could use Gemini, Copilot, whichever kind of generative AI tool you wish to use. You will also put in the link to this data source, which kind of has the average price data of different goods. So you can add more of these to the graph. You will then ask it to do things like analyze this data, give me kind of a summarization, or I think here the actual one was what good experienced the largest price increase. So you'll report what answer, right, AI gave you. Now, sometimes it'll be rather lengthy. So all you have to do is kind of summarize it and how it really answered this question. You'll then always have kind of these follow-up questions, which is, did that response, and so in this case, did it match up with what you thought looking at the graph yourself? Why might that dollar increase, the largest dollar increase for a specific good, which I'm kind of telling you what AI should tell you, why might it not have actually experienced the most inflation? And then kind of subsequent topics where I'll give you a prompt, ask you to kind of evaluate the response you got and think past what that prompt answered. So you only have to choose to respond to 2 of these 3. If I was doing this, I would probably enter all 3 into the generative AI. It's going to give you a little more accurate answers, but you really only have to pick 2 of these 3. 5 points will be given for each of those responses, right? 2 of those 3, each one worth 5 points. To have a complete response, you need to report, right? Summarize or state what the generative AI tool told you, and then also the subsequent questions that were involved in that topic. You have to have answered those as well. Once you make that initial post or response to 2 of those 3, you will then look at other students' responses, and based off of their answers to these questions, you will respond to those, analyze their evaluation of this generative AI answer, and then compare it to the ones that you got. Anything that your AI output differed from theirs, anything that you think their AI responses didn't capture that they didn't mention, and each of those responses to another student is worth 5 points. So you should have your own initial prompt or post. That's going to be choosing two of these three. You will then look at other students' initial prompts or posts and respond to two of them. Okay. Any questions on that Canvas discussion? You can't think of them now. If you're working on it and you have some, feel free to email me. But that will be due at the end of the day next Wednesday, because our first exam is next Thursday. We don't have class on Friday because of Independence Day. Okay. Any questions on that before we kind of jump into material here today? Okay. So we're going to do a little bit. Oh, there we go. Going to do a little bit of review, kind of where we left off. So we left off thinking about how we can determine real GDP using nominal GDP, how we can determine what GDP deflators are in certain years, and using kind of these two different versions of it's the same relationship, but two different equations, different versions of that, just rearranging things. So we went through an example with some actual numerical values, right? We then kind of said, what is that GDP deflator of the base year? It's always going to be 100. So I'll kind of work through an example to reiterate or kind of remind us again why that's true. And then what happens to our GDP deflator if prices increase or decrease? So when we're looking at a graph of this relationship, we talked about this last class, but I don't think we quite looked at this graph. So if I'm looking here, when would or what year would I be looking at is the base year? If it's the base year, it should always be that my nominal and real GDP are the same. So let's go through kind of the support behind why that's going to be the case. So we have this equation, which is my real GDP is equal to my nominal GDP divided by whatever that GDP deflator is, and then we multiply that ratio by 100. So anytime I'm looking at kind of my GDP deflator, and I should have probably wrote in here just to make sure I said it, but to make sure we're looking at the same. It's always going to represent kind of my, and think of this as the CPI, right? In my new year over that CPI in my old year. So if this is how I'm looking at that GDP deflator, right? And then I'm multiplying it by 100. Well, if I'm looking at the CPI in my new year, if I'm looking at the same base year, right, I'm comparing this to the old base year, this would always be equal to 1, in which case in the base year, our GDP deflator was always equal to 100. Now, moving forward, right, if I think about this GDP deflator, the way in which we calculate it, remember, it is going to be, so look here. I can think about, if I rearrange this equation a little bit, my GDP deflator, you could think of it as kind of through prices, but I could also use this equation where, if I just rearrange this, I've got the ratio of my nominal to my real GDP times 100. So anytime I'm looking at a year past the base year, what has to be true? Well, if I have prices that are higher, right? If I'm using those prices to calculate nominal GDP, but remember, real GDP use the base year prices. So if prices are going up, nominal GDP would always be greater than my real GDP. I'll give some further support behind this in a second. If that's the case, what would this fraction have to be? Well, if the numerator is larger than the denominator, I know that this would have to be greater than 1, in which case my GDP deflator would have to be greater than anything, 100 times anything above 1, it's going to be greater than 100. So anytime I'm looking at anything past the base year, typically we always have inflation, right? So if I have inflation, right, that means that our prices are increasing, which meant the nominal GDP would always be higher than that real GDP calculation. So anytime I have this price deflator being greater than 100, that's reflecting that nominal is greater than real GDP. It's greater than 100 when I have inflation and I'm looking at something past the base year. So kind of further support if I want to think about why this has to be the case. If I look at nominal GDP, that's going to be current prices times my current quantity. Real GDP are the old base year prices times that current quantity. So when would this be greater than 1? In which case I multiply it by 100. When will that GDP deflator be greater than 100? Well, this would cancel. So I'm really just left with my current prices over those old base year prices. The only way this fraction is greater than 1 is if prices have increased. So anytime we have inflation, we know that past the base year, our GDP deflator will be greater than 100. And then we can kind of think about the flip side of that, right? Using this same process, when will that GDP, or sorry, let's say we had deflation, right? And prices are decreasing. Well, what would that mean? Well, if my GDP deflator is that nominal over real times 100, if prices are lower today, well, real GDP controls for prices, so that shouldn't impact it. However, nominal GDP is using the current year prices. If prices have went down, that would decrease my nominal GDP. This ratio is now less than 1. So if that ratio is less than 1, what would have to be true, right, is that anything less than 1 times 100, my GDP deflator would now be less than 100 after that base year, but only if we have deflation. Typically, we always see inflation in our economy, so this is more often than not going to be the case, right? After the base year, our GDP deflator will be greater than 100, which then corresponds to that nominal is greater than real GDP. If we ever have deflation, that deflator is less than 100, which if I have my nominal over my real GDP, and this is less than 100, rearrange this equation a little bit, that would imply that my nominal GDP has to be less than my real GDP. So we left off kind of thinking about these relationships, but kind of going through them again or a little more in depth. I wanted to kind of start out with that today. Okay. Any questions on that before we keep moving here? So notice typically across time, right? This time period, we always have inflation. So the base year here, when real and nominal GDP are the same, that's going to be 2012. We know that the GDP deflator in this time period must be 100. Every time period after that, if I have prices increasing, I have inflation, my nominal GDP is increasing, but not at as high of a rate as my real GDP. Nominal is greater than real when I have inflation. Now, it's kind of weird to do this. I don't have an example of deflation here, but if I work backwards in time, well, if I had inflation, that means when I go back, prices must have been lower. So really, the same principle would apply as if we had deflation, if we instead look backward in time. So here, if I look backward in time, it's like I would have deflation, in which case that real GDP is actually greater than my nominal GDP. So let's take a look. I think the next one I have here is growth rate. So we're going to hold off on that. And we're going to come down here to our daily quiz, which is under this module 3 heading. So we will, let's start this here. double check. We should have 10 minutes, so more than enough time. So if I preview this, if I'm trying to ask or answer these questions, what has to be true? Well, I think this shouldn't be too bad when we're looking at one, because we've really covered this quite extensively today. So if I've got 2015 and I'm comparing that to 2020, 2015 is my base year. What must the GDP deflator be in 2015? Every base year, the GDP deflator, my nominal and real GDP will be the same because I'm using the same prices, same quantities, same prices. My GDP deflator has to be exactly 100. If production of all goods increases, right, and my GDP deflator is 95 in 2020, well, we said if my GDP deflator is less than 100, what does that have to imply? Well, we said anytime it's less than 100, that must mean my nominal is less than my real GDP. What was the only way that would occur? Well, remember, nominal GDP over real GDP. Nominal GDP uses my current prices times the current quantity. Real GDP uses those same current quantities. Remember, GDP is supposed to be a measure of output. We want to control for prices when we're looking at real GDP, so we use kind of the old base year prices. The only way that kind of this, if I have the fact that this GDP deflator, which I should have wrote over here, just to kind of make sure we're clear. The only way it's going to be less than 100 is if that ratio of the current prices to the base year prices, if this is less than 1, which would imply prices have went down. So the only way I would have a GDP deflator in that newer time period that's less than 100 is if average prices have decreased. Okay. Any questions on that before we keep moving? So let's work through a different kind of problem. So on number 2, if I know the nominal GDP in these two time periods, and I've got a GDP deflator in both of those time periods as well, what would my real growth rate be? So we haven't talked about growth rates quite yet, right? But in order to turn these nominal GDPs into real GDPs, I would have to use that price deflator. So assuming that 2024 is my base year, right? I've got kind of that GDP, or sorry, it's not my base year, right? Because I have a GDP deflator that's not 100. So what I would do in this case is I first need to turn these nominal GDP values into real GDP values. So if I'm looking here, no, I don't, forgot the values. So let me see. I'm gonna decrease this so we can see. Well, I'll write these down real quick to make sure. Put that in, right. So we had 2024, 2025, our nominal GDP values, and our GDP deflator was 500, 550, and we had 550, and our GDP deflators was 110 and 135. So if we wanted to calculate real GDP values, remember our real GDP would be our nominal GDP divided by that GDP deflator times 100. Okay. So all I have to do is plug in these values, right? For 2024, my real GDP would be the nominal GDP divided by that price deflator. I could then find my real GDP in 2025. That's going to be, just to be clear, this was a 0, divided by its price deflator, Now, if you then multiply both of these by 100, what values do we have here? So if I look here, so I've got my real GDP values. We could then calculate these here real quick. We could do this by hand, or we could do this in something like Excel. Right, so I'm just going to use Excel here. Maybe. There we go. So when we're calculating real GDP in both of those time periods, we had nominal GDP, the deflator, 500, 550, 110, 135. Okay. We then calculated real GDP, which was our nominal GDP divided by that deflator. And then we said we always multiply it by 100. So I've got these real GDP values. So notice once I control for prices, my real GDP has actually fallen. That must have meant that the price changes were kind of even larger than kind of the increases in output. So when I get rid of those prices, it looks like my real GDP has actually went down. So the next part of this question we haven't talked about yet, but I'm going to relate it to something we've already talked about. Okay. So if I want to calculate growth rates between two time periods, it's very similar to inflation. So my growth rate is going to be take the new real GDP, subtract my old real GDP, and then divide by whatever that starting real GDP was. And then to get growth rates as a percentage, we would then multiply by 100. So I take my new real GDP minus my old real GDP divided by the old year's GDP. This should give me a growth rate of what? Negative 10.37. Any questions on that before we keep moving here? So let's make sure response not displayed because it hasn't passed yet. So here I think, oh no, I had timed it out, but hopefully we've got more than enough time to make sure we're kind of getting those answers entered in correctly. Oh, and I think here I must have kept it in decimal form. So sorry, if you answered the one we just went through, I'll kind of have an additional answer in there so it counts that as correct as well. Now we'll talk a little more about growth rates. We can reflect them as percentages. We'll also talk about what happens if we don't. Any questions on that before we keep moving to talk more about these growth rates? Okay. All right, so kind of already showed you that growth rate formula. So if I want it as a percentage, I would take the change in my real GDP divided by the original GDP and multiply it by 100. So if I have this information, how would I do that? Well, it's basically what we just did, but using different values. So here, what I can think about is I'm going to go back to that Excel file. There's different tabs. Let's go back to this GDP and GDP growth rate. If I use, instead of real GDP, I use my nominal GDP. If I'm going to calculate my nominal GDP growth rate, so I'm just going to reproduce this answer. How did we do that? Here, I'll zoom in a little bit. See this a little bit easier. So when I'm calculating that growth rate, we said I'm looking for the growth between 2024 and 2025. So up here, I'm just going to calculate the growth rate between these two time periods. I would take my nominal growth rate minus my old growth rate and divide it by, my new GDP minus my old GDP divided by that original GDP. That would give me my current nominal growth rate. Now, if I hit enter here, I see it's about 0.05 rounded to the second decimal. In some later equations, we are going to use the growth rate as a decimal form. So any question you see on the quiz, pay very close attention to what it's asking for. If we don't want the growth rate as a percentage, we would just leave this alone. Typically, we want to reflect this, or we want to display this as a percentage. So what's the only thing we need to do? Well, to move from a decimal to a percentage, we simply multiply by 100, giving us that growth rate of 5.35. Now, if I do that, why would I then end up with a difference in my real growth rate? So we could do this example with these same values we looked at last class, determining what real GDP and nominal GDP was using that GDP deflator. So if I'm looking at real growth rates, how did I find real GDP? Well, I should just take that nominal GDP and divide it by whatever that deflator is. Well, I don't have my deflator here. I'm just giving you the values, but just to kind of reiterate, that's where that real GDP is coming from. Now, notice in both of these scenarios, my nominal GDP, if I want to kind of be just a more specific here, is greater than my real GDP. So what did we say has to be true about both these time periods? Well, if my nominal GDP is greater than my real GDP, I must be looking at something past the base year. So here we're looking at time periods past the base year. We can calculate growth rates. It doesn't have to be using the base year. So when we're calculating growth rates, it's the current GDP minus the old GDP. It doesn't have to be that the old GDP is the base year. Okay. Any questions, clarification that anyone wants on that idea before we keep moving here? So we would then use our price deflator. We calculated real GDP. Just to kind of reproduce this, how would I calculate my real GDP? Well, to turn it into percentage form, I'm going to multiply it by 100. What am I looking at? I'm looking at the change in real GDP. So my new minus my old. And then I'm going to divide that by my old original starting GDP. So if I do this, I end up with a real growth rate that's quite a bit lower than my nominal growth rate. So if we don't control for prices, well, when prices go up, it's going to make it look like my GDP or my output is going up by even more than it is. Real GDP controls for that price, so it's only measuring increases in output, not increases in output and increases in prices. So here, our real GDP is going to be, as long as we have inflation, always going to be lower than nominal GDP, which that same relationship would apply for our growth rates. Questions on the idea of kind of making these calculations before we keep moving? So we kind of have this growth rate. We went through some examples here. Before we talk about the next thing, I just want to relate this or kind of show the similarities anytime we're calculating these kind of growth rates. So when we were talking about inflation, we were using the CPI, but we could think about this as to get this in percentage format and multiply by 100. But what it was doing was it was taking kind of like my current year's prices measured by that CPI minus the older time period's prices or measured by that CPI and dividing it by the starting prices or that starting CPI. So this is really the same thing. What is inflation measuring? It's essentially measuring the percentage change in prices. But when we were calculating growth rates, we were calculating growth rates for our GDP or what should be measuring output. So when I calculate growth rates of my economy as a percentage, what that's doing is really the same format. It's just that we're going to be looking at real GDP in the current time period minus real GDP in the older time period. divided by whatever that initial starting point was for my GDP in the older time period. So it's a very similar calculation. It's just that for inflation, I was looking at the percentage change in prices. Growth rate is looking at the percentage change. Well, what does real GDP control for? It controls for prices. So calculating this growth rate using only what hopefully is capturing output, it's looking at a percentage change in output. So very similar calculations. It's just that here we're looking at prices for inflation. Here we're looking at just changes in output, which is reflected by real GDP to get my growth rate. Any questions on that idea before we keep moving here? So to kind of round out this discussion before we hop into module 4, what can real GDP tell us? Right? Well, if it's decreasing, we think about output is going down. We would call this a contraction in our economy. All right. This is the economy has poor health, right? We actually see output is going down. We'll talk some caveats to this here in a second. But for right now, we would think about these contractions as a recession, right? Lower real GDP tells us that there's a recession. The economy is producing less than it was before. Extreme recessions, generally the benchmark is defined as anything greater than 10%, right? A 10% reduction, we would call that a depression. So if the economy is instead increasing, we call this expansion, right? Or these are when our output is increasing. So what will growth rates be during a recession? Well, if output is going down and it's measured by real GDP, that means that in order, when I'm calculating these growth rates, if real GDP is now lower, that numerator, right? Oh, I'm gonna pause that. I'll get to that question here in a see. So prices, yes, right? When we're calculating real GDP, we're holding constant prices. And that's done so by we were calculating real GDP using that GDP deflator, which we kind of started out with class with. So if we have a recession, this real GDP value is less than what it was in the older time period, which means if this is less than this, our growth rates would actually have to be negative. Anytime real GDP in my current time period is less than it was before in the older time period, this change would be negative, so I would have negative growth rates. Right? So anytime I've got a recession, my growth rate is going to be less than 0. Anytime I have expansion or increases in output, my new real GDP is greater than my old, and so that would have to be greater than 0. So we're looking at some support of this. If I look at over time the US and its real domestic product, there are cycles, right? So we typically see that real kind of GDP, if I'm looking at the rate of change, yes, real GDP might be going up, but the percentage change in these time periods was greater than here. And then in some cases, that change actually goes negative. That's when we had recessions. So if we're trying to kind of identify some recessions here, looks like here it dips below 0. Here was a rather large recession. Looks like it might have just barely made that cutoff of a 10% reduction to be defined as a recession. I have to look at the actual values. I think maybe these are supposed to be -10 here. So we just missed kind of defining this as a depression. And then there's all this cyclical nature to our economy. And then, whoa, in 2020, why did we see such a large decrease in real GDP or a large negative growth rate? Well, we had COVID, right? A lot of things were shut down. Then the economy, why did the real interest rates spike so high? Well, if we're thinking about this calculation, where we start out matters when we're calculating growth rates. So if I have this huge reduction in real GDP, then even a small change, if this denominator is now smaller, would increase growth rates quite a bit. So anytime I have these large kind of decreases in real GDP, if GDP then goes back up, the new growth rate in that time period, because my denominator was so much smaller, is going to produce really high growth rates. But that's because the comparison point is the time period right before that. So notice once we kind of get away from that time period where we had this huge depression because of COVID, we're kind of now back to what looks normal. So these are our business cycles, right? Generally, we kind of have our economy kind of goes up and down. We'll call let's see if I have a slide. Yeah, there we go. So if I'm looking at, I think this is a smaller time period broken down by quarter. Anytime we see kind of this peak of real GDP, right, we would kind of think about after that, a recession begins, right? So this high point of real GDP, as soon as we see real GDP start to decrease, that would be identified as a recession has occurred. Now, once we get to the lowest kind of minimum point of this decrease in real GDP, once it starts going back up, right, we would kind of call the point at which it starts to increase again our trial. So these movements between the peak and the trial show us that real GDP is decreasing and increasing until it gets to the next peak. Then it starts to decrease again until it gets to its lowest point or the next trial, et cetera, et cetera. So what are some limitations of GDP as a measure of health of our economy? So if we wanted to compare, not within the same country, but across countries, right? What's a limitation of our real GDP? Well, let's kind of start out with this example where I've got China and Switzerland, right? The GDP of China, even if I've control for prices, is significantly higher. So one other reason why we want to control for prices is prices vary across countries. Once I've controlled for prices comparing real GDP, I'm really just comparing output. But why is this not surprising? Why is China's GDP so much larger than Switzerland? Well, China has a lot more people. Remember, some of the components of GDP were consumer spending. We've got a lot more consumers, right? So that's going to drive up GDP values. Even if we account for prices, that would be driving up real GDP, right? The nominal GDP is also influenced by output. So larger economies, right, that have more people, we would expect them to have significantly higher, even real GDP. Got more people, we're going to have more output. So if I use those populations, we can take it one step further and say, well, instead of just comparing real GDPs to see what country's economy is doing better, we're going to think about, well, how much is each person adding to GDP? Or calculate our GDP per capita or GDP per person. All we need to do that is take our real GDP. Now, here, everything we do from here on out, we're not looking at nominal, just to kind of make this point clear. We're only thinking about real GDP. So once I divide those real GDP values by the population, I now see that, in fact, GDP or per capita is actually much lower in China than it is in Switzerland. So this would be a reflection of the economy in Switzerland compared to China is actually doing better. Right? When we control for the fact that they have much smaller amount of citizens, a lot fewer citizens. Any questions on that idea before we keep? All right, so just to kind of put some additional values to this, and then I'll kind of add one more thing in before we complete this module. Let's say I had an example where I've got the real GDP of the US, and I have the real GDP of Canada. However, so I've got 1,500. So it looks like real GDP in the US is significantly higher than Canada. Why is that misleading? Well, if I then look at population numbers, and I'm keeping these numbers, they're not accurate, just kind of simple for us to kind of work with. If I calculate GDP per capita, and let's say that the population, so this is our real GDP, let's say the population in the US is 20, population in Canada is 5, well then when I calculate real GDP per capita, right, in the US versus Canada, 1,000 over 20 would be what, 50? And then if I take the real GDP of Canada divided by its population, I get 100. So once controlling for population, I get the exact opposite answer. Very similar to what we went through on the slides, but I'm using these numbers because we're going to add in one more thing. Any questions on this before we keep moving? All right. So there we go. So let's say instead of real GDP, let's say the example that we just worked through was nominal GDP. So if we're looking at that example, let's kind of start over. So if these weren't real GDP values, why would be using nominal GDP per capita of these two countries? So let's assume that these were nominal GDPs. Our GDP per capita ended up being what? 50 and 100. So even if we had nominal GDPs, we might think, oh, per capita, we might think, oh, Canada's economy is doing better. But what if we, what is nominal GDP not capturing? Changes in prices. So let's say we have significantly higher inflation in Canada, driving that nominal GDP when then calculating real GDP, that's going to drive it to be much lower. When we have inflation, it's going to increase that GDP deflator, pushing down our real GDP calculation. So let's say instead, the real GDP in these countries was, instead of 1,500, right? Once we account for prices, the fact that prices are dramatically higher in Canada, then the US maybe is 900, Canada's is 200. Now when we calculate real GDP per capita, here it's going to be what? 900 over 50 or 45. Whereas in Canada, we've got 200 over, what was our original population? 5. Sorry, this is not 50. This was 20, right, by population. So that ends up being 45, and then this ends up being 40. So notice, if we use nominal GDP per capita, we actually make a different statement about the health of these economies than if we use real GDPs per capita. So the end kind of story here is we want to account for the population, but we don't just want to do that for nominal GDP. We want to make sure we're looking at real GDP per capita. Now we've controlled for prices, we've controlled for population. This should be a more accurate measure of just the output per person of that economy. So here, why is nominal GDP misleading? We just worked through an example. It doesn't capture prices. Why is nominal GDP per capita even misleading? Right? Nominal GDP was misleading because we weren't controlling for the population. Nominal GDP per capita was misleading because we weren't controlling for prices. And we kind of worked through these in class examples for both. Okay. Any questions there before we keep moving? So that should round out our discussion of Module 2 material. So I'm now going to go to those Module 4 slides. All right. And I'm going to have that kind of Module 4 Excel file put open. We kind of looked at it a little bit here, thinking about growth rates. I wanted to introduce that concept that I knew we were going to talk about today, kind of relate it to what we've already talked about. So we look at Module 4 slides. what we're going to be thinking about here is, all right, we know that GDP, whether it's nominal, real, per capita, we want to use these measures to somehow see what's the health of the economy or how is the economy growing. So we said we want to use real GDP per capita. So I might shorthand this in this module and just call it GDP. But remember, we're now kind of just looking at real GDP per capita. So we mentioned before, every economic exchange, someone is purchasing the good, and then whoever's selling it receives the amount of money. We have the expenditure and the income approach to calculating GDP, right? So this is still going to apply to what we talk about today, right? Anytime somebody spends money, that money is going to the business, right? Anytime a household or employee receives wages, right? That business is getting output from those employees. So we have this circular nature of our economy. So if we then think about the production of our economy, right? Think about this as GDP. We're going to have a certain level of outputs of goods and services, right? So what's going to cause the production of these goods to increase? Well, if we have some technology change, even using the same amount of labor, we would end up with, or even if we had the same population, same number of workers, they're now more effective with this new technology. Think about this as the invention of computers. This dramatically increased what workers could do. So if we have technology changes, or we simply have more people, right? We said earlier, why were we controlling for, why did we calculate real GDP per capita? Because we know that population growth is going to increase our output. And then anytime we have changes in productivity, that's very similar to technology changes. It makes our labor capital more productive. All of these lead to the fact that using the same amount of resources, we can produce more. So using the same amount of resources, the different combinations, if we're using every resource in our economy, here was the number of the different combinations of goods and services we could provide. So if I have a fixed amount of resources, if I want to produce more services, I'd have to use more workers to do that, which means they're not producing physical goods. So if I'm looking at this and I'm comparing this to when we have these technology changes, population growth, or changes in productivity, well, I can then, using all of my resources, now get to even higher production levels of these two goods. So this kind of shift outward in what we would call our production possibilities curve, which hopefully you covered and maybe remember from B251, right? It's going to shift out. So we think about this in kind of a more applicable discussion. Everyone used to be quote unquote poor, or output levels used to be low, right? Over time, new technology, population growth, our economy started to expand. Now, we don't always see this month to month, right? Quarter to quarter, year to year. We already talked about in the previous module, we kind of have these business cycles. Sometimes we have recessions, right? So if I'm looking at overall, when we're calculating this real GDP per capita, it's controlling for inflation. So we've got real GDP per person. We notice most countries are experiencing increases in real GDP per capita. So they're experiencing increases in output, or what we would call economic growth. So we looked at this in the quiz question, but how do we calculate growth rates? Well, if I wanted to calculate growth rates not as a percentage, I'm simply looking at what is the change in my real GDP per capita divided by the change in my real GDP per capita in that starting year. So T is the current year, T minus 1 was the year before. So these growth rates would be in decimal form. If I ever wanted to convert them to percentages, just like anything else, we would multiply them by 100. So long run growth, or if I have growth in my economy, that should mean that everyone in my economy, their standard of living, the output, the goods and services available to them is increasing. So what's the only way I have positive growth? It has to be that my real GDP per capita is higher than it was in the previous time. Okay? This doesn't have to be true for short run growth, right? There could be a quarter where we see negative growth rates, but over the course of the year, they end up averaging out to be positive. Okay? So when we calculate growth rates, we typically want to look at longer periods of time because we know that day to day, week to week, we're going to have this cyclical nature of our economy. It's going to kind of have these ebbs and flows or peaks and troughs. So once we have real GDP per capita and we calculate these growth rates, well, we can now compare across countries, right? What economy is seeing more growth than others? So if we go back, we kind of worked through this example when we were talking about that question in the quiz. We can calculate nominal and real growth rates. We said that if we're using nominal GDP, similar to our examples from Module 3, nominal GDP is not controlling for prices. So if we use nominal GDP, and we were to look at that change in nominal GDP divided by the starting GDP, multiply by 100, so we have percentages here. The nominal growth rate is not controlling for prices. In most economies, we see inflation over the course of time. So nominal growth rates will always overstate what the actual growth in the economy was because they're not controlling for these increasing prices. Just as a thought experiment, what if I calculated my nominal growth rate as a percentage? I calculated my real growth rate as a percentage. If my nominal growth rate was something like 2.4%, but my real growth rate was 3.5, what would that have to imply? Well, once I control for prices, that gives me my real growth rate. How would nominal growth rate actually show that even if I had the same change in output, that my growth rate was smaller than that? Well, it would have to be that the prices I was seeing in the newer time period would actually have to be less than the prices in my older time period, or I must have had prices decreasing, or I had deflation. Okay? So it's very similar to kind of that relationship between nominal and real GDP. If my nominal growth rates are ever below my real growth rates, that reflects I must have price deflation. If we had the reverse being true, like in the example in the slides, that was evidence that prices are increasing, which is more reflective of what we see actually happen. If that nominal GDP was, instead of being less than that real GDP, it was greater than, we would have inflation in those scenarios. Questions on that before we keep moving? So we want to make sure we're using real GDP to calculate growth rates, because once again, growth rates, we want to reflect changes in output of the economy. So we need to control for prices. There we go. Now, if I'm looking at the difference between nominal and real growth rates, I can also think about, well, what did we say? When we're looking at interest rates, right? The real interest rate was the nominal interest rate minus inflation. So similar kind of thing is going to exist if I'm looking at real growth rates and nominal growth rates. My real growth rate will be my nominal growth rate controlling for prices or subtracting out inflation. So when we were looking at that Excel file earlier, we had the nominal and real growth rate. The difference between those two must have been the inflation that we had in the economy, because the nominal growth rate didn't account for that, the real growth rate does. Oops, it's not what I want to do. There we go. So, repeated the slide, there we go. I think I did right. Oh, no, this is a separate slide. I wanted to make a point. So let's say we had something like this. It's the same example, but I want to show you if I had left out this nominal GDP. If I know the growth rate, and I know the GDP in 2025, but I don't know the nominal GDP in 2024, how could I find that? So we'll kind of go through how we would solve for this. Using this idea, and this math, it's a little tricky, but I want to show you how we could solve a problem like this. So we were looking for the nominal GDP in 2024. Well, I know my growth rate as a percentage is 100 times the change in my real GDP. Now, in this case, we're not looking at real. The example I had set up was looking at nominal. So if we were doing that, it would be the nominal GDP in my newer time period, which I think was 2025, minus that nominal GDP in the older time period, divided by the original starting GDP or the nominal GDP in 2024. Now, we were told this growth rate was, let me see, I have to get the values here real quick. So we had, this was what, 5.35. We knew the nominal GDP in 2025 was this. So we're going to do this in Excel eventually, but I want to kind of show you how you would just do this in general terms. So I'm not going to use the values yet. I want to kind of show you if we rearrange this, how we could then use the values to determine what we don't know, which was this nominal GDP in 2024. So if I have this growth rate as a percentage, I'm going to move things around to solve for the nominal GDP, the one thing I don't know. One equation, one unknown. So the first thing I'm going to do, take that growth rate as a percent. I'm going to multiply both sides by the nominal growth rate in 2024. That would cancel this out. So I'm left with just my nominal growth rate in 2025 minus that, sorry, not my nominal growth rate, my nominal GDP in 2025 minus my nominal GDP in 2024. Now I'm trying to solve for this. So I'm going to move this to the other side. So I've now got my nominal GDP in 2024 plus that nominal GDP in 2024 times that growth rate as a percentage. And I technically forgot to write it here, right? We had multiplied by 100. And then I'm left with 100 times that nominal growth rate in 2025. But this isn't what I'm looking for, right? I have that value. I'm looking for this. So I'm going to rearrange this equation a little bit. This was one of the values that I knew. I'm going to pull this. It's the same in both of these. So if I take my nominal GDP in 2024 times 1 plus that growth rate as a percentage, I now can divide both sides by 1 plus that growth rate as a percentage. So 100 times nominal GDP in 2025 divided by 1 plus that growth rate as a percentage. Now I have an equation that solves for that missing, oops, sorry. I now have an equation, thank you. I now have an equation that solves for what I was missing. So let's use these values and actually look at this in Excel. So we have this Excel example, oops, not here, this GDP and growth. So let's say I don't know what this is, and we just said the equation that should give that to me was 100 times whatever nominal GDP was in 2025 divided by 1 plus the growth rate. If I do that, hopefully, oh, what did I do wrong here? So I had 100 times my nominal GDP times 1 plus the growth rate. Oh, actually, sorry. What I have here. Is this not giving me the value? So I take nominal times the old nominal. Oh, sorry. So I wanted old nominal divided by 1 plus the growth rate. Yeah, so I'm actually not getting the correct value here. Because what I need to do, right, the equation I just wrote out, and I think I mentioned this earlier, when we're looking at growth rates, we can represent them as percentages, but when I'm doing these actual calculations, right? So make this point, when I have growth rate as a percentage, I have actually a little bit more difficult math because this is technically my growth rate times 100. Right? So this instead I'd be dividing by my growth rate times 100. So I forgot I had this, so I wanted to kind of reiterate this concept. So if I simply took this and multiplied kind of both sides by 100, I don't get the right pattern. What I would actually need to do is make sure I'm dividing that growth rate by 100 because I'm using the decimal form, and I no longer need, right? I'm not showing this as a percentage. I want to make sure that I'm using the decimal form of that growth rate. Sorry, this is what I want to show you. This was supposed to be. So this is what I plan multiplying it by 100. Oh, it's not giving me what I want. Oops. Here, we'll kind of keep it at this, not that I want to cause any confusion. What I actually kind of need to be doing here is using that growth rate in decimal form. So this would be what I want to make sure that I'm doing. So I could also, work in the exact opposite. If, I left out this real GDP or I left this, I would just have to make sure in that calculation I'm using the real growth rate as opposed to nominal growth rates. Questions before we keep moving on this? Saving a little bit of time left here. So even though we can display those growth rates in percentage form, when we're making this calculation of looking at old versus new GDP, we want to make sure the growth rates that we're using are in decimal form. So just before we kind of look at one other topic today, I'll kind of rewrite this, another thing that could be useful when we're working through some of these problems. So let's say instead, usually what we're wanting to do is we think about, we're not trying to go back in time, we're trying to make predictions about future or new time periods. So the way that I would calculate my kind of new real GDP is I would actually take my old real GDP and multiply it by 1 plus that growth rate. Now, when I'm using these equations, once again, I don't want this in percentage format. I want this as a decimal. Okay. So I want to make sure I'm using the decimal form of this. This should always give me kind of what that new GDP would be. So in fact, we can hopefully show this. If I go back to that Excel file, let's say I took my old real GDP. I then multiplied that by 1 plus my real growth rate. However, remember, I want it in decimal form. So if I wanted to do that, I could just put 0.024 or I divide it by 100. Sure enough, that gives me my new time period's real GDP. So I can make predictions given what current growth rates have been or the trend in growth rates. I can make a prediction for what my new real GDP would be. If my real GDP is lower than that, it must mean my growth rate was lower than what I predicted. And then if it's higher, it means my growth rate was even higher than what I expected. So why do these growth rates matter? All right, so we'll kind of have this separate Excel file, but I'll set this up and then we'll jump back into it. So here we've got kind of not just one time period, but we've got, what if I wanted to make projections out for 20 years? Well, what ends up being true is that we can still make predictions for future time periods, but every single year that GDP is getting, you can think about, multiplied by 1 plus the growth rate. So once again, this growth rate here we're going to use is in decimal form. So if I have my old GDP, if I wanted to calculate new GDP, say in 20 years, I would need to take 1 plus that growth rate to whatever power I'm wanting to make that prediction out for. So I want to make a prediction for 20 years, n would be 20. Once again, growth rate just as decimal form. If I wanted to, give this percentage of the growth rate, if I am given this percentage of if I am given the growth rate as a percentage, I'm talking too quickly, I would take that growth rate as a percentage and simply divide it by 100 to get the decimal form of it. Okay. Now, over time, right, these even small growth rates can matter a lot. So let's say I start out with 100 or $100 billion. I then am going to think about how can I calculate new real GDP, starting real GDP was 100, at these various growth rates, but I want to project out 20 years. So I'm going to open up that Excel file again. We're going to zoom in a little bit here. Get my arrow, grab the corner. There we go. So let's say I want to make projections out for 20 years. So I'm going to get rid of this for a second. And I'll add this in. Using what we talked about before, why did these growth rates in 1 year don't look like they matter a whole bunch? I mean, they're only, going from 2% essentially to 3% to 4%. Well, I would take that old GDP of 100. Now, to make this point, this is 100 billion. I could use Excel, and I have that entered into a cell. This will help me here in a second. I would then take that old GDP, multiply it by 1 plus the decimal form of this growth rate. That should give me my new real GDP the following year. So, I wanted to freeze that cell reference, sorry. Forgot to do that, right? I'm still using 100 million, the same old GDP, but I'm updating the growth rate. Well, okay, the growth rate's going up, but it doesn't, look like it's not increasing my real GDP by a significant amount. However, if I want to calculate or make a prediction for my real GDP, what will it be in 20 years? Well, we said there, we will take the old GDP value, right, of 100, and then going to multiply it by 1 plus that growth rate. Okay. Plus that growth rate, but I'm then going to take that to the power of how many years I'm wanting to make this projection out for. So I'm going to freeze this cell reference, because my old GDP and the number of years is the same for each one of these different scenarios. So I can see here, okay, in 20 years, a relatively small growth rate increases my real GDP by a significant amount, right? I mean, if I make the calculation here, right, this is like going from 100 to 148, that's just below a 50% change, right, in my new real GDP over the course of those 20 years. Now, if the growth rate just goes up by a little bit over the course of 20 years, notice the difference in my new GDP is not just 1 in each kind of these scenarios, it ends up being significantly higher, right? That change here for this growth rate of 2 to 3%, I'm going from 148 to 180. So I'm going up by approximately 30. But then if I go up same 1% increase in my growth rate over 20 years, it increases real GDP instead of 180 to 220 or an additional 40. So the jump here, even though it's the same change in the growth rate, the change in my real GDP is not just 1. Over 20 years, it starts to grow significantly. So this is the same idea. I don't know what other courses you've taken up at this point, but it's the same idea as compounding interest. Essentially, that's what's happening here. It's compounding growth rates as opposed to compounding interest. So, don't underestimate the power of compounding interest. It's the exact same thing. Don't underestimate the power of compounding growth rates. Even relatively small growth rates over a long period of time can cause our real GDP to increase rather significantly. Now, I think, just so we kind of revisit this a little bit, I'm going to hold off on this rule of thumb. We'll revisit this idea of growth rates and kind of why even small percentage in the growth rate matters and kind of a general rule of thumb that we have. So we'll revisit this on Monday's class. We'll then kind of transition to thinking about long run, what kind of impacts these growth rates, like what are some factors that impact long run positive growth rates and higher positive growth rates. So we should kind of be able to finish that fairly. I think we'll be able to cover all of that on Monday. So in which case we won't just have one day where I can, we can do review. I'm actually going to be able to do a lot of review on both Tuesday and Wednesday of next week. So once I get those practice problems for the next quiz up there over the weekend, start reviewing those, review the old practice problems for quiz 1. Once the due date passes tonight for quiz 1, start to review kind of that quiz. Any questions that you have, bring them. I'll still have a live session where we're just doing review. I'll have a set of questions I might bring in and try to work through. But I think those are going to be the most effective if the people attending live are asking questions that you have. So other than that, just kind of where we're at, what we should be doing over the weekend prior to Monday's class. That module 4 reading is not due until we start class on Monday. So we've already kind of dipped our toe into module 4 a little bit, but that's not due until we cover the an entire class period of module 4. So that's due before we start class on Monday. Make sure you're getting on. I get this Canvas discussion done as quickly as possible. That way you don't have to worry about it next week. You can start studying for the exam. And then if you haven't already, make sure you're completing that quiz 1 by the end of the day, 11:59 Eastern Standard Time today. Okay. Any other questions here? I'll stop the recording here. And then if you have any other questions,